And well, before I start, I guess, is there anything you have questions on about, well, no, it's fine. It's fine. We'll just start into topic 2 here. So hopefully you've accessed this on D2L already. If you haven't, well, at least, go to D2L if you can, grab the notes, or at least have a notebook, because, anytime I'm writing things, you should probably write it down too. I try to make it as clear as possible that way. But today we're just going to cover just this little portion, which is definition of a function and function notation. So there's only a few of you here right now. There's only 6 of you. How many of you have actually watched the video that I posted yesterday? Just so I can get an idea.
I didn't.
No, okay, that's fine. I figured you wouldn't because I posted it so late. Anyone else? Not yet. That's fine. I'm just going to basically cover this as if you haven't watched the video, but I'm not going to cover the same problems that Tom covers in the video, because then once you do watch that video, you'll have a bigger picture of everything, if you know what I mean. But I'll cover enough so that you've got a picture of the topic, all right? So it's about functions and function notation, which maybe you've seen before and maybe not. The big idea here, the main idea when we talk about functions is we're talking about inputs and outputs. So if you had a situation where, let's just say we have some function, which can be seen as just some mysterious box. We have things that go into it, and we have things that come out of it. And of course, in math, that's generally going to be numbers. It doesn't always have to be numbers, but it's going to be numbers most of the time. Let's just say I put in the number 2 into this, and it gives me back the number 5. Well, every time I put the number 2 in, it should give back the number 5. Maybe I put in the number 4, and it gives back the number 7. So we can probably imagine that maybe the function here is x plus 3. X being the input, and then it spits out an output. So for example, it takes this 2, it adds 3 to it, and it gives us back a 5. Or it takes a 4, it adds 3 to it, it gives it back a 7. This is kind of like the most basic function we can have. In the book here, it says functions are when one quantity, usually y, depends on another. It says it's a function of the second. And we have things called dependent variables, which are generally y, generally speaking. We have independent variables, which are generally x. So the reason that it's called dependent and independent, let me just put down a quick example. Let's just say we had a function that looked like this, y equals 2x plus 1. That function will take the x value right here. It'll multiply it by 2 and then add 1. So which one of these variables depends on the other? Well, this y is what we call the dependent. And the reason is it changes depending on what we put into it. If we put a 1 in for x, it gives us a special number. It depends on that x to know what it is. If we put a 10 in for x, it'll give us something different. Of course, it depends on that x to know what it is. Another way of looking at this is that independent could be seen as the input. We can put in whatever number we want. But of course, whatever number we put in changes what we get out of it based on the function. So let me try to give you a basic example, like a real life example. Let's just say you had a group of 10 friends who all wanted to go to a movie. Now, of course, we can't really do that right now because of COVID and all that, but let's just say things get back to normal and you go to the movies. And we have, you have 10 people. Let me just write it off to the side. Let's just say you had 10 people and you want to go to the movies, and the tickets are 30 real tickets, okay? You have 10 people that go to the movies. We know that we're going to have to pay how much? Well, we're going to have to pay 300 real for 10 people. We can make this into a function because the cost that you get out of this depends on how many people go to the movie. If one person goes to the movie, it's 30 real. If 2 people go to the movie, it's 60 real. The amount of money you pay depends on the input. So the way we could wrap this up is we could say the cost, y, depends on whatever the x value is, the input, which is and multiply it by 30. That could be like seen as a rule. So long story short, we have this value here, which is the independent, or also known as the input, what we put into it, and it spits out, according to some rule, the dependent variable, also known as the output. Okay, I'm just trying to throw everything at you at once so you get an idea of what I'm talking about here. So, dependent, independent. You'll notice that the dependent is usually the variable we solve for, but we'll get to that in a second. So, there's three ways to look at functions, and I'll make a big note of this. This is extremely important. There are three ways to represent a function. The first way is an equation, which I've already done. So for example, I could say y equals x squared. That could be an equation. The second way would be a table of values, which I'm sure you've done before. You look at the x values and what do we get out of the y? You know, when we put an x value in, what does it spit out for y? And then the third way is a graph. So maybe we have something that looks like this. It's just three ways of representing a function. So all of this was explained in those videos, but I know many of you probably didn't watch them today. So I just wanted you to get a picture of what's going on. Okay. Hello to everyone who's slowly coming in here. Nice to see you. I'm looking at the class list. I just don't have time to say hello to every single one of you. So example one, A and B were already done by Tom in the video, so you can go and watch them later, but I'll do C for you so we can see what's going on here. It asks us to do two things. It says rearrange each question to find the function, and it says state the independent and dependent variables. What this means is isolate a variable. It means isolate. I'll write it in different words. Get one variable alone. So bring it to one side. It's also called isolating. And depending on which variable we get out of this, it'll tell us what our dependent and independent is. So let's look at this equation. Do we want to solve for y or do we want to solve it for x? Can someone just give me an idea here? You know, in the chat, you can just say x or y. Those of you who are doing the assignment right now, you know, you got lots of time to do that assignment. You should be paying attention to the class instead. Anybody?
Y.
Okay, y. Y sounds fine. Why? Let's say we want to try solving for y. So let's see, we want to solve for y. It's in two places. So it might be a little bit extra work, but yeah, Sarah says it doesn't matter, and I'm inclined to agree with Sarah. Sometimes it does matter. In fact, in this question, I probably would have gone with x first because it looks easier to solve for. It's only in one place. Let's solve for y and see what happens. So we have 7y plus 3x equals 8y minus 15. Now, of course, we want to get it to one side. So I'm going to bring this guy over here. And I'm going to bring the x's to the other side. That'll be 7 minus 8. 7 minus 8 is negative, so negative y equals negative 15 stays where it is, and then minus 3x becomes on that side. Now, we don't want negatives. You know, that's actually technically a negative 1 next to this y. We want to get rid of that. And how do we get rid of it? We divide everything by negative 1. You can also think of it as changing all the signs. So what do we get? Y equals 15
plus 3.
3x. The only thing I'm going to say is normally we like to put the x's first. It's just standard. So I'm going to go ahead and do that. Y equals 3x plus 15. But really, both answers are perfectly fine. So that's what we mean when we say we want to make it a function, or we want to rearrange it so that it is a function. Now, it asks us to know what the dependent and independent are. So we'll say y here. Which one is it, independent or dependent? Well, y equals some rule. Y clearly depends on what we put in for x. If we put 1 in for x, it'll change it. If we put 2 in for x, it'll change it. So y is the dependent. It depends on x. If you put a different x in, we get a different y. X, on the other hand, we are allowed to put whatever x we want into this thing. So that's the independent. That's why they're called that. Another word for dependent, do you remember what it is? What's another word for dependent? Output. What it spits out, what it gives us after we put a number in for x. All right? So different ways of saying the same thing. So in this case, this is our rule for.
So we didn't have to find the value of x and y?
No, we don't actually need to solve for the values. In fact, it's impossible because we have two variables in one. We only have one equation. We'd have to solve for two unknowns. It's not possible. So we just need to rearrange it. And we could actually graph that. In fact, that's what I'll do. I'll show you. You can get this on your calculator, Desmos. I just want to show you, you can graph this really simply. So let's just graph this guy here. So y, let me move this around. Y equals, let's see, 3x. My keyboard keeps coming up. 3x plus 15. Okay, and it looks like this. Sorry, I'm trying to get everything organized nicely. That's what this graph looks like. Okay, it's just a straight line. It relates the two things. I'll come back to that in a second. I'll bring it all around in a second here. So what about if we solve this for x? Remember, there's two possible ways we could do this. I'll just split it up. If we chose x, well, let's see, we want to solve it for x. That means we'd have 3x stays on the left, and then we'd have this on the right side. Yeah, bring it to the other side. So it'll be minus 7y. Okay, how are we going to get that for just x? Well, firstly, I'll make sure the right side looks nice.
Y minus 15.
Yeah, 8 and 7. Y minus 15. We want x isolated. We want it all on its own. We don't want anything else touching it, so we should remove that 3. So divide everything by 3. And I'm going to divide each term separately. And the reason for that is it makes the equation nicer in the end, okay? This gives, I'm going to call it 1 over 3y minus 5. Oops, 5. Now, some students, I'll just write it to the side. 1 over 3y is the same as y over 3. And depending who you are, maybe you want to write it y over 3, maybe not. I'm always going to be writing it with the number in front because that fraction tells us a lot of information. It helps us later, okay? So I'm always going to write it in two pieces, the fraction and then the variable. But let's get back to the point. This is our function. Which one is our dependent? So x here, is it dependent or independent?
Dependent.
Dependent, exactly, because it depends on what we put in for y. If we put in a different y, it gives us a different x. And the other word for that is output. Y must be our independent. You don't need to write the full word. I'm just writing the full word for you.
Sir, how do you know if it's dependent or independent?
Okay, so I'll give you sort of the short answer. The dependent variable is what you solve for. Okay. The dependent is the one that's alone.
Yeah, but y is alone too.
On this side,
Oh, okay.
right? So it depends. Depending on how you solve it, it can be either one. You can, if you solve it for y, then y is the dependent. If you solve it for x, then x is the dependent.
Okay, okay.
Got it?
Yes.
So let me go ahead and quickly graph this one again. And some of you might be like, why is he graphing all this? Well, it will help later. Well, at least I think it will. So this is, I'm going to graph 1 over 3, x equals 1 over 3. I recommend you get this on your phone, by the way. It'll help you a lot later. Minus 5. Okay, look. These graphs, sorry if that's distracting, just look at the graph on the side here. This red graph and this blue graph are exactly the same. They're exactly the same line, which means they are actually the same function. They're saying the same thing in two different ways. So I'm just trying to show you, you can see functions as graphs as well. We'll do that more later. So long story short, when you're asked to get a function like this, when you're asked to rearrange it, first thing you do is choose the easier variable. And then once you've solved for it, you just write down which one's dependent, which one's independent. So I want to look at this D. Which variable here is easier to solve for?
Why?
Yeah, I agree with you, because when I look at this, these are all power 1. This power 2 is going to be a little bit tricky to solve for. It's going to give us a square root. I'm going to say we want to avoid any square roots. So if we can avoid the squares, we can avoid getting square roots, and that's a good thing. The reason for that is it becomes plus and minus of something and blah, 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 blah. So just, we're going to solve for y. I'll just put that down. We're going to solve for y. That means it's going to be our dependent. Let's see, we have, I'm going to keep my y's on the left side. You can choose to put them on the right. It doesn't make a difference. So negative y is already there, but I'm going to bring over the 2y, and I'm going to bring over the 3y. Now that's everything. 9y is already on the right side, but I need to bring over the 2x squared. And now I'm almost done, actually. There's not a lot left to do. I need to combine like terms on the left side. So that will give us negative 6y on the left. On the right side, there's not much to do, but I am going to switch the order. Because I want the bigger power first. I'm just going to say bigger powers, like the squares. I want them first. Okay, that's the only reason I switched those. What do I do next? How do I get y on its own?
Divide by minus 6.
Yeah, divide everything by minus 6. Some students, don't write this down, some students do this, and they end up confusing themselves because they find it difficult to simplify. What I'm going to suggest you do is take each term and divide it by the negative 6. And you're less likely to make a mistake that way. So I'll cancel that 6, because of course it divides by negative 6 as well. And then I end up with y equals. Now what's negative 2 divided by negative 6? It's 1 over 3. And then what's 9 divided by 6? It's 2, wait, I should know this, 1.5.
Sir?
Yep.
Can you send me the link of this Zoom? Because I want to send it to Daha, because she can join. She doesn't know how to join.
The link 221-246-8025. I just wrote it in the chat. Can you see that?
Yeah.
Yeah, it's always the same one. All right, is there anything left for me to do here? It looks like y is on its own. Is there any other simplifying I could have done?
No.
I don't think so either. Now, some students ask me, well, how do you know when you're finished? You know, like if you need to simplify, well, if everything has a coefficient and an x bit and a coefficient and an x bit, and they're all in smallest form, like you've canceled terms and stuff, you're probably done. So it's solved for y. Y now depends entirely on x. So that's the dependent, also known as the output. The x here is the independent. And that's the input. So that would be kind of how those questions go. Is there anything I can clarify before I have you do a couple quick practice problems?
No, it's easy.
Yeah, it is easy, but I want to make sure that if it comes up later, you get full marks on it. All right, if you need me to go back to it, let me know. I want you to try C and D. C is a little bit tricky. I'm going to remind you. Try to avoid square roots. And D, there's two possible answers, okay? So what I'm going to do, I'm just going to turn off the audio and video. Try C and D. As you do that, I'll write my answers for A and B. so we can compare them later. You can have full solutions, okay? So just it should only take about 1 minute to do both of these, but I'll give you 2 if you need it. Okay, so I'm seeing the trusty Abdullah answer here for C. We'll see what we get. Anybody else give it a shot? All right, let's see. And 1/4 y squared. Yeah, looks the same to me. Okay, so that's about enough time for those. I definitely agree with those answers. Again, we want to avoid square roots, so we're going to make x equal something. Or in other words, I'm going to solve for x. It's going to be my dependent. So I'm going to rewrite this so that the x is on the left. That's just personal preference. Now divide both sides by 4 and we got our answer. There's no need for square roots. We're just finished. We solved for x without any real headache. X now is the dependent because it's the output, or it's the isolated. Y is the independent. All right, so whoever said those 2 answers, so Abdullah, Tarek, anyone else who got that, you got it right. For D, I've said there's 2 possible answers, and that's because it's equally easy. It's just as easy to solve for y here as it is to solve for x. So I'll just split this into 2 pieces. Let's just say I went ahead and solved for y, which is the nice normal way we're used to. That gives 2y minus y equals x plus 3. And these 2 are, of course, the ones that moved across the axis. This gives us this. Y equals 4x. You're saying y equals negative 4x? I'm not sure. You might want to check that one. I don't know if it's negative. For solving for x, I'm going to keep the x where it was and move the other x over. Keep the y where it is, move the 2y over. It's negative. It's negative y. So what I get is 1/4y. So Tarek, you have negatives, some sort of negative problem popping up there in both your answers. So make sure that you check that. I do not think it's negative. How do we feel about that? I want to show you it on Desmos in a second, but Everything okay?
Yep, we are fine.
It's the ultimate silence. All right, let me show you. Again, many of you, if you know how these graphs work, if you know how functions work, this won't be news to you. But for some of you, and you might have never made that connection between equations and graphs. And equations always give graphs. We just don't always graph them. So I'm going to take B here. I'm going to say y, I'm going to move this around, y equals negative, and you should get this on your phone. It's got a great app. You can do this while I do this so that you don't fall asleep, you know. 2x squared plus 3x plus 1. Now this function, this is what it looks like. And the reason it's nice to know what the function looks like is it tells us how the graph changes based on our x values. So for example, our graph can tell us directly if we put in x equals 0, for example, let me just stretch this out. If we put in x equals 0, what will the function be? Well, it should be 1, 0, 1. Or if we put in, let's see, some points here. Let me make this more clear for you. If we put in x equals 0 to this function, we should get back the number 1. Well, is that true? If I put in x equals 0 for this?
Or during the assignment or test, do we have to graph them?
That's a bit of a tricky one because some of you don't have a printer necessarily. So what we'll probably end up doing is, first of all, you should have some sort of basic graph paper or go get some. But at the very least, you need to be able to sketch them. And so what I would always recommend is you just literally just do the same thing I do. Use Desmos to see the graph on your phone, and then you can sketch it on paper because none of the graphs are that complicated. So just to finish my train of thought here, the function, if I put in 0 for all these x's, what does this give me? Well, it gives me, this is 0, this is 0, it gives me 1, which means when x is 0, y should be 1, which is exactly what this graph is giving me back. But the nice thing about graphs is that it does it for every single possible x value in the entire universe. So if I put in 0.75 for x, it gives me back 2.125. You can check that yourself. Or if I put in 1.781, it'll give me back 0. You know, if I literally put in -2 times 1.781, square that, I'm just looking at this, plus 3 times 1.781, plus 1. It gives me a tiny, 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 tiny number, which is essentially 0, okay? Maybe I've lost a few of you. Maybe you're thinking about the assignment, stressing out. But I just want you to show, I want to show you that every single function has a graph associated with it. All right, and that's kind of all I had to say about that. So let's move on to the stuff that's in the notes. Form 2. I'm assuming there's no questions on that. Form 2, table of values. So what are the 3 ways to see a function? Equation, table of values, graph. Every single equation can have a table of values or a graph associated with it. What we're doing here, it says a function can be seen from a table of values if there is a one-to-one relationship between the independent and the dependent. Let me try to make that in clearer English. Every input has to have a unique output. So let's look at this table here. I know this was already done in the notes, but I want to do it clearly. Think about the number -2. If I put in the number -2 to this magic function machine, what number should it spit out? Well, it tells me it's going to spit out -8. Are there any other numbers here that it's giving me for -2? It looks like -2 just gives -8. But in this case, it looks like if I put in -1, what's it going to give me? It's going to spit out 2 different numbers. It's going to give me a -2 and a 10. That's not okay. That's the same idea as if you went to the movies and they said, okay, it's 30 reals, and you walked away and you're like, great, awesome, good price. And then someone else came in and they made them pay 10 real. You'd be like, what the heck? Why is there a different rule for you? Well, you can't have two different cases, two different outputs in the same function. Otherwise, it's not a function. You know, functions are straight rules that cannot be broken. So we can say not a function. Let me do the next example so you can see. In this case, look, -2 goes to 3, not a problem. 1 goes to -1 goes to 4. 0 goes to 5. 1 goes to 4. 2 goes to 3. Perfect, no problem here. So it's a function. It's not breaking the one-to-one rule. Let me show you exactly what I mean by this one-to-one rule. In practice 2 here. Does the table of values represent a function? That's our first question. If it does not represent a function, tell us why. So for example, 8, what does it give us? 14, all good. 9 gives us 12, no problems yet. 10 gives us 10, 11 gives us 8. So we don't know what this rule is necessarily, but it should be a function. I'll go back to my trusty Desmos one more time, just to show you that you can do all this on the calculator. It can help you. I'm gonna make a table. I'm gonna put in 8, give back 14. I'm gonna put in 9, give back 12. I'm gonna put in 10, it gives back 10. And put in 11, gives back 8. What does this give us? It looks like this. So we can see there's a rule, right? We can see there's a pattern. And if we followed this pattern, it would probably continue to follow this rule, or at least we would guess. Now I'm just giving you a sketch, but that looks like a pretty nice pattern to me. So it probably is a function. Let me get rid of some of these annotations here. So let's try, okay, yes. I'll say it is a function. Sorry, I'm just trying to make it as clear as possible. Function, yes. Why? There's a 1-to-1 relationship. What it means is unique input. Sorry, inputs give unique outputs. What about B? Can someone tell me if B is a function or not?
No, it's not a function.
Why not?
Does -1 have two solutions?
-1 has two solutions. Let's see, -1 gives a 1. And -1 also gives a 3. So that's bad. So that's already, right away, we can say it's not a function, but I want to check. Also -2, actually. -2 gives a 0. -2 also gives a 4. That's also bad. Again, that's like going to the movies and someone, you have 10 people, they give you a cost, and then another group of 10 people comes in and they give you a different cost. And you know, they're not VIP or something. We're just talking about normal people here. Function? Question mark? No. Why? Not 1-to-1. What 1-to-1 means is that you give one number, it gives the same number back always. Every time you put in a -2, it should give back the same number. If it doesn't, then it's not a function. It's something else. It's just a relation. And those are totally different things. All right? So I think that's about it for that table of values stuff. It's pretty simple. I'm not going to go into it anymore. I also want to make sure I cover enough today because you have that assignment starting at 11:50. What I will say is, this was noted by another student. It was Jocelyn, actually. I don't know if he's here. I opened the assignment too early. So that was my mistake. I meant to open it 30 minutes by the end of class, and I opened it super early. So some students got a head start. And so to make it fair for everyone, every single student in all the sections, for my sections, have until 2 o'clock to do the assignment, okay? That is the only time I will do that because I just made a big mistake. It happens, but it works out for you okay. You got to get it to me by 2 o'clock, okay? That's just assignment 1. And you can do it anytime you like, all right? So lots of time. but they'll normally be half an hour. All right, form 3, graph. Well, big surprise, you can graph functions. We've been seeing this all day already because of the way that I've introduced it. The way we're going to check if a graph is a function is we're just going to simply do the vertical line test. And you can read this if you want, but the vertical line test is super easy. All you need to do is literally draw a vertical line. So I've drawn a vertical line. If that vertical line touches anywhere more than once, it is not a function. So instead of maybe drawing the line, what I like to do is take a pen or a ruler and move it across the page. So how many times is it touching here? It's touching once. Once. At every single point, it's only touching once. So the VLT, the vertical line test, is passed. It's a function. All right, it passes the vertical line test, which is literally you draw a line down and you only touch once. So it's a function. In this second case, it doesn't matter where I draw it. Actually, you know, I could draw it anywhere on this circle or ellipse, and it would touch at least once. Sorry, at least twice. Boom. That's not good. We say it fails the vertical line test. And if it fails the vertical line test, it's not a function. That's because, for example, if I put in this x value, it's giving me this y value and this y value. Well, make up your mind. Which one is it? You know, if I go to the movies, I want one, you should use one rule to make me pay for that ticket. Not 2 rules, not 3 rules, not 5 rules, and so on. So long story short, vertical line test. If it touches once, you're good. If it ever touches twice, you're not good. Try these practice problems. They should probably take you about 3 to 4 seconds each at maximum. So just write your answers in the chat. I want to get an idea of who's following along here and who's not. Take 30 seconds. You can't hear me? Is there something wrong with my microphone? Okay, I've got enough answers to go with here. And Ali, maybe I might have muted my microphone by accident partway through a sentence. I didn't mean to freak you out. Still here, still alive, whether you like it or not. But yeah, okay. So all of the answers I saw here coming in are all correct. I'm just going to quickly draw my line, but of course, you just use your hand or your ruler or just look at it. Right here, it doesn't matter where I draw this line, but I'll move it around a little bit. Okay. It's always touching twice. So it's not a function. In B, I'll move my line around. It actually doesn't matter where I put it. It will only ever touch once. So yes, it definitely is a function. It passes the vertical line test. So many of you came in, at least 7 of you. So good job. For the third one, once again, it doesn't seem to matter where I put the line. But sometimes it's tricky, so let's see. Nope, always okay. Yes, 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 yes. Doesn't matter where I put the line, it is a function. It's a function. And then the third one is the only one that I find ever confuses students. I'll try to make a thick blue line so you can see it. This function on the left side, you know, if I was only looking at this part, let me make this bigger. If I was only looking at sort of the left region, it would be okay. Sorry, I think I've made my computer freak out a little bit. Yeah, if I was only looking at this region here, it'd be okay. And if I was only looking at this region here, it'd be okay. But anything in here touches 3 different times. That's definitely not okay. So I'm actually going to draw 3 lines just to make it crystal clear. Here, oops, here is perfectly fine. Here is perfectly fine. The center here is definitely not okay. And as soon as it fails it at any point, we're done. You know, this story is finished. It's not a function. As soon as we break our rules, essentially. As soon as different people get different costs for a movie, it's a bad thing. Not a function. Now, this isn't like a bad graph. It's still fine. These still exist. They're just not functions. And that'll come up later, what that really means. All right, I'm sure that's very simple. So if I ever ask you to perform the vertical line test, you got this. Slice it down the center and see if it touches once or not. I'm assuming that's all good. Just got to take a quick look at what I wanted to accomplish next. Okay. So, is it all good? Can I get a thumbs up? I know no one ever goes on video, but you know, you can thumbs up in the participants list, or you can type a yes, or you can say all good in the hood, or
All
other
good,
things
yes,
that
all
people like me talk about. What'd you
We're
say?
good.
We're good. Okay. All good in the neighborhood. So the last thing we're going to cover today is function notation, which I kind of already talked about. Tom in his videos definitely talked about this. But what it means is functions. Usually you want to know what goes into a function to give an answer. So for example, if it was function of x, that means the function depends on an x. And we say f of x, function of x is what that means. We can write y equals, let me make this more clear. Y, the y that we normally see and we love, y equals, well, you might not love it. Let's just say it was 2x plus 1. We can make it more clear if we use function notation and call it f of x. Because it tells the whole story now. It says the function depends on x in order to get a number. So let me go over to this little dream sequence here. I know you can't do this, but I do have a QR code right here. You know, if you scan that with your phone, it'll bring up this function builder if you want to play along, as it were. But let's see, equations. Okay, so give me a number between 1 and 3, or plus or minus 1, plus or minus 3. No, just a number between 1 and 3. Anybody?
2.
I'll take the first number, 2. Okay, so 2. Boom, done. And give me a number between -3 and +3.
-3.
Thank you. So minus, let's see, 3. All right, so what this function does, this is obviously some sort of weird tube, but essentially what it does, it is a function. It takes numbers and it does stuff to them, which is all functions do. So let's say I put the number 0 into it. 0, it's going to multiply it by 2, so it's still 0. It's going to take away 3, and what am I going to get out of this? It should transform it into a -3. Magic. Magic math tube. Mathmagical. What if I put the number 1 into it? It'll follow the same rule. Multiply it by 2, it's now a 2. 2 take away 3 is -1, so it should come out a -1. Yes. Man, what a cool little machine I've made here with your help. What if I put in a 2? Well, 2 times 2 is 4, take away 3 is a 1. What if I put in a 3? Times 2 is a 6, take away 3 is a 3. Let's keep going. Let's look inside this tube and see what happens. What if I put in a 5? Well, it's now 10. 10 take away 3 should give us 7. So it spits out a 7, and so on. What if I put an x in? X times 2 should come out 2x. What if I do 2x minus 3? Well, there's not really anything I can do. I think I'm going to get 2x minus 3 out of this. And I do. So the rule is 2x minus 3. Let's look behind the curtain here. This is if it was in table of values. You'll notice that I can represent it all as a table of values if I want to. What's another way I can represent it? The equation. So this is actually the function that takes x's is 2x minus 3. Put in any x, it'll spit out a new value, f of x. What do you think's behind door number 3? What do you think's behind this third tab? Whoever answers correctly gets an extra question answered by me or something equally useless. Anyone? Anybody? Am I talking to the ether? Going once, going twice. What's behind door number 3? The graph. So every function has 3 things. It can be said it's an equation. It can be said it's a table of values. And it can be said that it's a graph. And in this case, this is clearly a linear graph. So the relationship goes up and up and up nice and easily. Let me do function notation. What if I wanted the value f of 6? Well, that would be easy to do. We replace every x. So I'm looking at this now. I'm replacing every x with a 6. I'm putting 6 into this function. It's eating it, digesting it a little bit, and spitting it out. That's kind of gross, I'm sorry. 12 minus 3, so it should give me a 9. What if I feed it a 6? Feed it a 6. 12 minus 3 is 9. Okay, so it does spit out a 9. That's all function notation means. Okie doke. We all good with that? I can't tell if anyone's still alive out there. But
Yeah,
if you're
good.
alive, just say hi every now and then so I don't feel so alone. It's so lonely in here. Okay, long story short, how do we do the actual math? Well, Tom did example 6. I'll do some of these examples. Evaluate the given functions. Okay. This is our function, f of x, so it depends on x, is 3x minus 5. Okay, so this is all you do. You put 7 in for x. You know, every time you see x, make it a 7. And that is all you need to do. So the value of this function when x is 7 is 3 times 7 minus 5. So I probably don't need to do this, but I'm going to make it blue so that you see this very clearly. Of course, I've changed it. Oops. And then 3 times 7 is 21 minus 6, that should be 16. Minus 5 is 16. Halas, we are finished this question. D was done by Tom. I'd like you to put some answers out for B and C. We're almost done this, topic. I want to make sure that you're following along. So can you just try B and C? It should take about 20 or 30 seconds each at most. I'm not sure if you could hear me right then, but I wanted you to try these questions. B is 1, let's see, maybe not. Ooh, 1 over 5.
1 over 5, yeah.
So I'm getting 2 answers for 1 over 5, 1 answer for 1. Ooh, 3 answers for 1 over 5. I think we might have a winner, so I'm going to start working on B. You guys can work on C. Or guys and ladies, of course. Don't mean to let you down. So we're putting a -2 into this guy. I always put them in brackets, always, because if it ever has a negative, it will take care of it for you, especially if you put it in on a calculator like this. So that gives us 1 over 5. Or 0.2, same. 25. So I'm getting some answers 25 for this guy. 1, 2 answers. How many more 25s we got in here? 3 25s. 4 25s. So I think we might have a winner for 25. Again, you should see these are not complicated, but the reason I spend so much time on them is that whenever these skills come up again later, you'll have a good foundation. You know, you can't build a big building on sand, or you certainly shouldn't. You know, build it on a solid foundation, then you can build it brick by brick. So now you've got a solid foundation. Let's see if it's 25. I'm going to put 3 in every time I see S. Notice this means function of S, f of S. 3 squared plus 4, put a 3 in, minus 5. First, I'm going to replace these every time I see them. And that gives us, what, 18, 12, minus 5. Or you can put it all on your calculator at once. And that's 25. So excellent. Anyone who got 25 for that, which it looks like many of you did, 100%, nothing to worry about. Once I said also that D was done in the video, which it is, but if you wanted to check your answer later, it's x squared plus 2x plus 26. But I'll leave that as an exercise for you to do, because you need to be watching these videos too. By the way, anyone who's curious about the survey, I don't have all the answers in yet, but I have about 3 or 4 students left to go. Most of the students, and by that I mean more than half, chose to keep things the same, which means Tom's videos first, Scott's classes second. And so expect that that's going to be the way things will continue. If it does not continue that way, I'll be sure to let you know, okay? But I'll share the results of the survey a little later. Okay, so we're almost finished. What time do we got here? I guess we have 3 minutes left. So that's time for me to do one more question, and then you can have your time to do the assignment questions. So in this case, it says given 3 functions, f of x, g of x, and h of x, they are 3 different rules for x. They all change x in different ways. They're different machines that take values and do different things. I'm going to try B here, and then A, B, and D you can, of course, do on your own. So h of 2 plus f of 4. Well, what is this? This is, now I'm going to look at h. I need to take 2, and then every time I see x, I need to replace it with 2. Plus 12 minus 2 squared plus f of x. So every time I see x in that function f, I need to replace it with 4. So this is what I should get. All right, these are, that's our, oops, this is our blue function. And our pink function, it's not pink, is over here. When you solve that, what you should get, if my workings are correct, is 12 plus, which should have given a -4, which is the same as 8. All right, so the only thing I did, I had 2 functions to deal with instead of 1. And so I just looked and said, okay, what's my rule for this one? And what's my rule for this one? And followed those rules accordingly. Any questions on that before we stop for the day?
No, sir.
Clear? Clear as mud, as they say back home. Hopefully that's all right. I'll do one last bonus thing because I have 30 seconds left. If you want to read a value from a graph, all you do is look. Watch this. Find f when x is 2. So find f when x is 2. You just go find x equals 2, and you say, hey, what must be the accompanying y value? Well, it's 3. Y must be 3, which means that the function when x equals 2 is 3. All right, everybody, I'm going to keep this open. I'll stop the recording here. Bye-bye, everybody that's listening.